Okay, this is lesson 6.1b, and the title here is that we're going to solve rational inequalities. Okay, when I do one of these, the first thing I want to do here is I want to set it not necessarily equal to 0, but pull everything to one side, so it's either greater than or equal to, or less than or equal to, or less than or greater than 0. So on this one, what I'm going to do is bring 2x over x plus 1 over, so I'll have minus 2x over x plus 1, and then that'll give it to me greater than or equal to 0. Now, all the problems on this lesson are really easy at this point because they always give you common denominators. If I didn't have a common denominator, what I would have to do is find it so I could combine those two fractions. But since I have a common denominator right there, and my common denominator is x plus 1, and so on the numerator, this is going to give me 1 minus 2x. Okay, so I set it equal to sort of equal to 0, and then combine it as one fraction. Now, here where things get a little different, what we're going to do is look at something called the critical points. So critical points are what make the numerator 0 and the denominator 0. So I'll say what makes the numerator and the denominator equal to 0. Okay, so in this case, if we look at this one, and what we're going to do is we're going to plot those critical points on a number line. And we'll move this out of the way. Okay, so let's be thinking here of those critical points is what makes the numerator and the denominator 0. So for the numerator here, if you set that equal to 0, that would give you a positive 1/2. I'll put a positive 1/2 on my number line. And then what would make the denominator 0 would be -1. Okay, now here actually comes the solving process. To solve the rational inequality, what we're going to do is we're going to pick numbers that are in these three intervals here. So since I had 2 critical points, that's going to divide it up in 3 intervals. Of course, the more critical points we get, the more intervals that we would have to test. So let's start over here. Let's sort of go left to right, and we're going to test this interval. So what I want to do is pick a value that would be in that interval. So that would be anything that would be on this side of -1. So to make things easy, I'm going to pick a nice number. I'm going to pick -2. And so I'm going to test -2 here. So I'll take -2 and substitute it into the rational inequality here. So when I substitute -2, I'm going to get 1 minus 2 times -2 over -2 plus 1. Okay, so let's see. This is going to give me positive 4. And then 1 plus 4 would be 5. Okay, and on the bottom, -2 plus 1 would be a -1. Now, I really don't even need to go past this. What I need to look at is this going to be positive or negative? So when I test -2, this comes out to be a negative. So the way I tell if this portion over here of the graph is a solution, well, have to see, is that greater than or equal to 0 right there? So is a negative greater than or equal to 0? No, it's not. So this region is not a solution. Okay, now let's test the middle region. Okay, so this one in the middle here, or that one on the left side didn't work. Now we're going to test the one that's in the middle. So I want to test a value that's in between -1 and positive 1/2. So a nice number to test there would probably be 0. Okay, you could do any number in between, doesn't matter. but I'm going to test 0 here. So if I plug 0 into my function, I'm going to get 1 minus 0 over 0 plus 1. So that's going to give me 1 over 1, which is positive. So we're going to ask ourselves here, is a positive number, again, greater than or equal to 0? Well, that would be yes. So that means 0 works. So that means anything in this interval right here would be a solution. So what I'm going to do is I'm going to shade this part right here. Okay, now as far as the endpoints go, we'll talk about that in just a minute. Okay, for right now, we're just going to leave them open. Now let's go to the other interval. So my other interval over here is something bigger than a half. So what I could do for that one is probably test 1. So let me test 1 here. Okay, so I'm plugging in 1 now. So do 1 minus 2 times 1 over 1 plus 1. And so that'll give me 1 minus 2. That would be negative 1 over 2. So the point is it negative? Well, a negative is not greater than or equal to 0. So this interval wouldn't give me a solution either. So I only have the numbers that are in between negative 1 and 1/2. So notice the question asks for me to write my answer in interval notation. So I'm going to write interval notation off of my number line there. So I'm going to write my answer. We'll move this out of the way. Now, as far as the endpoints go, what we look at is sort of a combination of things. If this value of negative 1 makes the function undefined, then I cannot include it. The other thing that I'm going to look at is if it's greater than or equal to, or is it just greater than? Okay, so we know that the equal to means I would include my endpoints. So the thing is, though, I cannot include negative 1 because negative 1 makes it undefined. Anything, any x value here that makes it undefined, I cannot include. So at negative 1, that one's going to be open. But at 1/2, because it's equal to, that means this one would be closed. And so even though this right here was greater than or equal to, negative 1 makes the function undefined because that would make me divide by 0. So again, anything that makes the function undefined cannot be included, so it would have to be an open dot. Now, so if I just put this in interval notation, that's pretty simple there. That would be negative 1 to 1/2 and then a bracket. Okay, let's look at another one now. Okay, so again, I'm going to set this one to 0. So we'll get negative 2 over x plus 5 minus x over x plus 5 is greater than 0. So I could write them over a common denominator. Okay, now let's plot our critical points. These are actually a little easier. It's only 2 critical points here. So let's look at what would make the numerator 0 and the denominator 0. So negative 5 would make the denominator 0. Now let's think what would make the numerator 0 here. Get negative x equal 2, so x would be negative 2. Okay, so now let's go through and let's test some points here. Okay, so if we wanted to test this interval, okay, we could choose probably negative 6 there. So let me plug in negative 6. We do negative 2, that would be plus 6 over negative 6 plus 5. So that would give me 4 over negative 1, which is negative. Okay, so I got to see, is that true or false? Well, is a negative greater than 0? No, it's not. So this first section is not going to be a solution there. Okay, so let's try the middle section. So something that would be in between here, -5 and -2, I could say maybe -3. All right, so let me substitute in a -3 and test -3. So they'll give me -2 plus 3 over -3 plus 5. That's going to give me 1/2. And so we got to think, is 1/2, or that's a positive number, is 1/2 greater than 0? Yes, it is. So we're going to have this section be a part of the solution. Okay, and we'll do the endpoints in just a minute. Okay, let's do one more test here. We have to test parts over here. So something that would be over there, I'm going to use 0 since that's pretty easy to substitute. So that would just give me -2 minus 0 over 5. That's going to be -2/5. That's negative. And a negative is not greater than or equal to 0. So it's not that part either. So my solutions is what's in between. Now let's see what we're going to include or not include. Well, this is just, again, greater than, and it's not greater than or equal to, so I'm not going to include either. Okay, so I'm not going to include -2 because of that. And no matter what this said up here, even if it said greater than or equal to, I couldn't include -5 because -5 would make that undefined. And so now in interval notation, this is going to be -5, -2. Let's see. Third. Okay. Okay, this one's a little different. We've got less than or equal to on this one. So 2 over x plus 1. And now I'm going to say minus -x over x plus 1 is less than or equal to 0. Of course, here if we want to, we can just distribute that negative sign, and that would just be plus a positive. So I'm going to get 2 plus x over x plus 1. Okay, so let's do some critical points here. My critical points would be -2 and -1. Okay, so let's start testing some values. So over here, starting with the left side, I could choose -3. So I'll get -3, excuse me, 2, and then that would be -3 over -3 plus 1. Let's see, that's going to give me -1 over -2, and which is positive. So it would be a positive 1/2. So let's look and see, all right, and let's think, is 1/2 less than or equal to 0? A positive number would not be less than or equal to 0, so we don't have that section. All right, so let's go with something in between here now. So something in between -2 and -1 might be -1.5. So I'm going to substitute that one. So let's say 2 minus 1.5 over -1.5 plus 1. So this would give me 0.5 over -0.5. Okay, that's going to be a negative number there. That'd actually be -1. So let's see, let's test that. Is a -1 less than or equal to 0? Well, a negative would be less than a positive. So we're going to have the middle section again here. Okay, now let's try this right side. So over here on the right side, we could probably test 0. So that would give me 2 plus 0 over 0 plus 1. So that would give me 2. That's positive. and a positive is not less than or equal to 0. So we only have the middle section now. Now let's look at the endpoints. We do have an equal to there. So it is less than or equal to, so we would might to think include the endpoints, but I can't include an endpoint if it makes it undefined. So notice which one of these makes that undefined, and that would be the -1. So even though it has an equal to, I cannot include the -1. So that one would be an open one. Now I can include the -2 because I have the equal to right there, and -2 doesn't make it undefined. So this will give me the solution here, -2 to -1. Okay, last one here. All right, again, I'm going to set this equal to 0. So I would subtract this. So we'll say all that greater than 0. Now notice I could factor that, and it would be a common denominator. That would just be x plus 2 times x plus 1. And then on the top here, this is going to give me -4 minus x. Okay, so we're going to have a lot more critical points this time. It's going to be a little bit more time consuming here. So let's start with a numerator. Let's think what makes here the numerator be 0. So I'd take that -4 over and add it, and then divide by the negative. And so that would be a +4. And then on the denominator here, what would make those 0 here? That would be -2 and -1. So now we've got a lot more intervals to test this time. So let's start off over here. And so we could test -3 there. All right, so really what we need to do when we test is we don't need to really see if the number, to see if it's greater than 0, all we have to do is see if it's positive or is it negative. So I'll go a little faster this time. And so if I test -3, if I plugged in a -3, let's see what that's going to give me here. -4 plus 3 would be a -1. Okay. And on the bottom, if I plugged in -3 there, that's going to give me a negative. So notice I'm not even going to write what they are anymore. I'm just going to write positive and negative signs. -3 plus 2, well, that would give me a negative. Okay, so those would go away, and so that's going to give me a negative there. Okay, so -3 results with a negative. So a negative is not greater than 0, so it won't be that part. Now, let's go in between here. So what I could test there would be a -1.5. Okay, so let's put in -1.5, -4, and then plus 1.5. That would be negative. And then -1.5 plus 2, that would be positive. And then -1.5 plus 1, that would be negative. Okay, so those negatives would cancel, and so that would be a positive. Okay, so a positive is greater than 0, so I'm going to have these values including the solution. Okay, now to the next interval, from -1 to 4, I'm going to choose 0 there. So if I'm going to test 0, if I plug 0 in, that's going to give me a negative on the top. And then plugging in 0 on the bottom would give me a positive times a positive. It'd really be +2 times +1. But all we're doing here is just signs. I'm showing you a little quicker way here. So that would be a negative over a positive, which results in a negative. So 0 is not going to work because a negative is not greater than 0. Okay, so that interval is not working. So we got one more interval over here finally. We're going to test 5. So if I plug in 5, let's see, -4 minus 5, that would be -9, so they'll have a negative. And then when I plug it into the denominator, that's going to give me a positive times a positive. And so that'll be negative over positive. So this gives me negative. . negative. . negative. 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 And so as a negative is not greater than 0, so this would not work either. So my solutions here is just what's in between. Okay, and notice it's just greater than, which means I couldn't include the endpoints, and I couldn't include these endpoints even if it was, because those endpoints is what makes it undefined. So that's going to give me a solution now from -2 to -1.